Hey guys, this is Sahia here. So over the last couple of days, I've been getting a couple of questions about how to configure a Cisco router as a DHCP server with multiple VLANs. So basically, that's what we're going to be doing here today. So as you can see, I do have a couple of PCs at this end. I also have a switch here, and these PCs are all on their individual VLANs. I've already assigned the access ports that's running through the switch. This interface on the switch is the trunk, and the PCs are accessing the router via their sub interfaces. So all the multiple VLANs you see here, they are all configured on the router but on the sub interface of F00. So I have previously configured VLAN 10 and VLAN 20. So what we're gonna be doing is configuring VLAN 30 and VLAN 40. By that you should have an idea of how to configure that. So that as you can see in my DHCP database, I already do have VLAN 10, as you can tell from the IP addressing 192.168.10.11. so that 11 is the first available IP address from the subnet, because I also did exclude a couple of addresses from the subnet, basically to assign to servers and other switches if you want. And for VLAN 20, you can see we do have 192.168.20.11, also the first available IP. Now the hardware address we are looking at here is for the NIC on this PC. The same goes for this. I didn't indicate at least time for the IP address. That's another parameter you can set. But let's first go ahead and work with VLAN 30 and then VLAN 40. So what you first want to do is to create the sub interfaces for those VLANs on the router. So that's what we're going to do. So the first thing you want to do, conft, and this is really important. That it's kind of easy, but it's also a little tricky along the lines, so you have to be careful and organized as you go about this. So the interface we're going to work with is the FOO interface, but is the sub interface of FOO. So you can see it like underneath FOO you can create multiple interfaces and assign them with IP addresses without messing around with the physical interface. There is a protocol that is used to have that function properly, and so that's what we're going to do. So you want to do interface F0, and then normally you want to use for identification purposes, you want to use the VLAN number to match the interface. Down the line, it makes troubleshooting easy, and also for visual purposes. So I'm going to use 30 for my sub interface on FOO sub interface. So you want to do enter, and now the interface just pop up. And now you want to assign, before assigning an IP address, you want to invoke the protocol that makes that possible. So it's encapsulation. You can do a tab and do tab encapsulation.1q. This is the protocol that makes sub interfaces functional at the router's level. So now what is important here, the sub interface, the .30 that you see here, it should also match. That's where the mapping takes place. It should also match what will be the .1q number. So since that is 30, we want to use 30 for that, and then you put enter. Now your IP address that you're going to use here is going to be your gateway address, because that's how routing is done from the from the router's point of view. So you want to assign on a sub interface, you want to assign the VLAN gateway address to the sub interface, not an IP address, okay, but the gateway for that VLAN. That's what you want to assign to the sub interface with on the router. So you want to do 192.168.30.1. I like to do my addressing basically in these manner because it's sort of easy. And they want to give a subnet address, a subnet mask 255.255.255.0 is the /24 network, and then you do enter. You can also give it a description to remember. So I want to do VLAN 30 link on arrow 1. That's enough. After that, you've created the sub interface for VLAN 30. Next, to evoke DHCP, you can move on to do the next step. So what we're going to do is this. So you want to exit out of here. To evoke DHCP, to enter DHCP mode, you want to do IP DHCP pool, and then you want to give it a name. For visualization, you want to give it the same VLAN that hold the network. So you want to do VLAN 30, okay. IP DHCP pool puts you within the DHCP configuration mode. Now you want to specify the network, all right, the network of the VLAN that you want IP addresses to be sent to, because when broadcast comes to the router, that's how the router going to understand which VLAN is sending a requesting for DHCP address, and also understand where to forward those IP addresses. So the network for that will be 192.168.30.0.255.255.255.0. all right. And now you want to do the default router. The default router can be the next hop router or the gateway of the network. So since it's just there's no next hop router instead, so we're going to use the gateway for the network for this in this comment. So we want to do default router 192.168.30.1. okay. Next, you want to exclude couple of addresses. You could choose normally people would choose the lower end of the network to exclude, or you could do the higher end of the network. So what do I mean by that? So you want to do IP DHCP excluded address, all right, 192.168.30.1. all right. You don't want to assign the gateway, so you want to exclude the gateway as well. So you want to start that, and then this will be the first. This is basically the first address that's going to be excluded, and then the next set will be the range. So you want to give a range, a beginning and an end. So the DHCP server wouldn't give up those set of addresses. So I like to do 10, 192.168.30.10. So with this command, basically the first available address within the mind of the DHCP server is 192.168.30.11. all right. You do enter, and that's it. You exit out of there. Let's put this to test. This should work just right. If all the configurations are right, this should be easy. So you move in here, and then you do DHCP. We should be good to go. So as you can see, 192.168.30.11 30 is my VLAN number, and is my second octet if you reading from right to left as we normally do. So it's my second octet, so that is correct. 255/24, my gateway 192.168.30.1, so that should be just about right. And now to test that out, we can ping to the router, and that should work. Alright, so let's see whether they can all talk. They are all talking because we do have inter-VLAN routing going on by use of the router. Inter-VLAN routing going because of the router. But this wouldn't talk to this because there isn't anything functional on this PC as of yet. So that is good. So if you didn't understand the first time, let's run over this very quickly, and then we will see how it goes. So like I told you, the first step is you want to first create the sub interface for the VLAN. So that's what we're going to do. intf is 0/0 dot. This puts you right into the sub interface of the VLAN. Okay, that is on encapsulation .1q. Now you want to match the VLAN number with the .1q number as well. So that's how the mapping takes place. And they want to do IP address is always the gateway for sub interfaces. IP add 192.168.40.1 255.255.255.0. Okay, you can give a description, VLAN 40 link on arrow 1. Okay, that is settled. You exit out of there. Now to create a DHCP set of addresses, you follow these steps. IP DHCP pool, and then you provide a name for the DHCP pool. So for identification purposes, I just give it VLAN 40. Okay, now you want to specify the network 192.168.40.0. that's the network. The 0 is the network. Okay, remember, if you are familiar with subnetting, you quite understand that the 0 is always the network. All right, so 192.168 .40.0, then the subnet max 255.255.255.0 is a /24 network. If you enter, specify the default router. In our case, we don't have a next hop router. What we have is a switch. So this switch is basically serving as a dummy switch. All right, it's an access switch, so it sits between the LAN and the router. So what we do have functionally that do all access ports for our VLANs. So there's not a next hop router, so we're gonna use the default gateway of our individual VLANs for the default router as specified in the coding. So default router, you do type 192.168.40.1. all right, next we're gonna do sort of exclude couple of addresses. IP DHCP excluded. For some reason this one doesn't work with tab. Let's see, doesn't take it. Excluded address, you want to specify the lower end of the address, a range of addresses that you have excluded, that you would like to be excluded from being distributed to hosts on the network. So 192.168.40.1, 192.168.40.10. so basically what we have here is our first available address in the mind of the DHCP server is 192.168.40.10. sorry, 40.11 is the next available address in the mind of the DHCP server. You do enter and it should be good. Let's do right man. Okay, that should be fine. Next, you want to come here and let's see whether we will pull our address from the DHCP server on the router. this should work just fine. Like I told you, that's it. Very easy, but we have to be very meticulous about how you go about it. All right, so 192.168.40.11, like I told you, our first available address will be 40.11. 255 is a /24 network, and our default gateway is 40.1. So that is great. Let's test that out. That should work just fine. Now we are also experiencing inter-VLAN routing. What you should understand, they are passing through the same switch, but they are not on the same VLANs. In order to do inter-VLAN routing, you have to introduce a router on the network, and to have that possible, you want to configure sub-interfaces on the router to enable inter-VLAN routing. Without the router, if you had a switch here, trust me, these VLANs wouldn't be able to talk to each other because they will all be on separate VLANs. Alright, so that's just about it, to sort of give you an idea. Show IP DHCP banding. Okay, so we do have at the moment four VLANs within our VLAN database, and we also do have the hardware addresses as well. So I can see all the available first addresses at .11, 10.11, 20.11, 30.11, 40.11. all right, as you can see, the VLAN numbers also correspond with the set of addresses you see in the VLAN database. So basically, that's just how it should work. It's fairly easy. Once you have an understanding of it, it can be a breeze. So I'll also later on during a different set of live, I will introduce a different set of VLAN here and a couple of routers to enable either to introduce RIP version 2 or OSPF to have routing from both networks or across the networks. So guys, let's hope that served the purpose. If you don't mind, kindly subscribe to my channel. Hope you enjoyed the video. Thank you once again. My name is Sadia, and I'll see you around. Bye bye.